I'm a researcher at Fraunhofer ISI since almost 10 years and work on a circular low-carbon industry strategy. And together with my colleague Simone Zanoni from the University of Brescia, we will discuss with you today, especially paths for circularity and decarbonizations of the manufacturing processes. And in today's session, we have a very strong focus on the automotive, e-mobility, and battery sectors. We have 4 presentations that dive into these issues, and after each presentation, we will have about 10 minutes time for a question and answer session. So please, we kindly ask you to post your questions in the session Q&A in Wova, and also add the person you want to dedicate your question to. With that said, I want to introduce our first speaker, which is Senatro. Senatro is researcher at the Institute of Methodologies for Environmental Analysis of the National Research Council of Italy, and his research activity is focused on energy systems analysis and modeling, with a particular concern to the development of partial equilibrium models. And today he will talk about a multi-region approach for the automotive sector with the time energy model. And so, Senatro, the floor is yours.
Okay, good morning to everybody. My presentation deals with the innovative application of the times energy model generator to automotive manufacturing plants. Next slide. These are the contents of the presentation. Next slide. The application is in line with the principle of the circular economy, where waste is considered a resource which can be reintroduced in the production cycle. This approach has many advantages compared to the linear economy. Next slide. Aim of this study is to explore the potentiality of the circular economy, implementing a partial equilibrium model based on the eceee times model generator to analyze the energy and material system of an automotive industrial district on the time horizon 2015 to 2025. The scenario analysis allows to individuate the least cost solution. Next slide. Next slide. The eceee methodology is usually applied to different scales. It is based on the linear programming and on optimization of the total system cost to satisfy the final demand. The structure is mainly focused on the energy system with a detailed representation of technologies. Next slide. Next slide. Okay. The times for cars model modelizes 2 different units, utilizing the multi-regional function. The plastic unit, where starting from polypropylene supply, the plastic components are produced, and the assembly unit, where the cars are produced. 5 types of cars are producing, and they represent the final demand. The reference here is 2015, for which model is calibrated to real data provided by industries. Next slide. Next slide. Okay. The model structure is made up of Excel sheets, which represent the basic structure of the model, the new technologies database, the scenario files, and the tried files from unit plastic to assembly unit. On the right side, as an example, we can see the reference energy system of the plastic unit from import of natural gas and electricity to their consumption in the molding and painter processes. Next slide. We have analyzed 6 scenarios. The above scenarios, which represent the evolution of the current energy and the productive system, and 5 alternative scenarios. 3 energy scenarios and 2 scenarios related to the plastic materials. The photovoltaic scenario based on the introduction of photovoltaic system, both on the plastic unit and assembly unit. The energy recovery scenarios assess the economic feasibility and the effects in terms of energy of the introduction of organic Rankine cycle technologies for the energy recovery in the molding processes, and the syngas production scenarios assess the introduction of a pyrogasification technology coupled to an internal combustion engine, both in assembly unit and in the plastic unit. 3 types of syngas are hypothesized on the basis of different concentration in moles of polypropylene, mixed with municipal solid waste. The pigmented scenarios assesses the convenience of using pigmented polypropylene during the molding phase. Recycling scenarios assess the convenience of the recycling system, taking into account the investment cost and the quantities of waste produced in the plastic unit. Next slide. As concerns the above scenario, starting from 2019, the current cogeneration systems are replaced by 2 steam turbines with bleed and cogeneration condenser for both the 2 units, characterized by higher efficiency. The energy consumption per car is decreasing on the time horizon. Next slide. As concerns photovoltaic scenarios, the total cost increases by 1.2% for the assembly unit and by 0.8% for the plastic unit, respect to the above scenarios, and lower natural gas consumption for both units and lower CO2 emission. As concerns syngas production scenarios, the model prefers to use the syngas type 3, characterized from 60% of most concentration of the polypropylene. The total system cost decreases by 3% compared to the above scenario, and in both units there is a reduction of natural gas consumption. Pyrogasification technology is activated from 2019. Next slide. Next slide, sorry. As concerns energy recovery scenario, the organic Rankine cycle technology for energy recovery in the molding phase are not selected due to their high investment costs. If a superimposed exogenous constraint forces the use of technology, the system chooses to activate those not integrated with a renewable source. We have lower consumption of electricity and cooling in the molding process, and a lower electricity production by steam turbine, and a lower import of natural gas. The compressors for cold production show also a reduction in electricity consumption, CO2 emission decreases, and there are not changes in heat production and consumption. Next slide. Pigmented polypropylene is a particular material which allows to avoid the binder process, but it is characterized from higher costs of waste disposal. The results show lower natural gas purchase, lower natural gas consumption for cogeneration system, lower heat losses, lower electricity consumption in compressors for cold production, and lower CO2 emission from combustion, and obviously zero emission from a binder process. Next slide. As concerns the recycling scenario, in absence of constraints on the reuse of scraps from a plastic component, the model suggests waste disposal of scraps as the optimal solution in terms of total system cost. The sensitivity analysis suggests the system is economically convenient with an investment cost of €10 per kilogram. Next slide. This work was useful to validate the feasibility of modeling a specific industrial district for cars production using the Times Energy Modeling Platform in order to evaluate the possible implementation of measures based on the principle of the circular economy. The results show that steam turbines with bleed and cogeneration condenser are introduced to replace the current system of electricity and heat production for both the two industrial units analyzed. The installation of photovoltaic panels for both industrial units leads to a reduction of natural gas consumption and consequently a reduction of the CO2 emission, causing an increase of the total cost of the system due to the investment in new technology. Introducing ORC technologies into the molding process is not economically viable, despite saving 30% of energy for electricity and cooling. Next slide. The use of regasification combined with an internal combustion engine for electricity production is economically convenient for both production units, even if a modest quantity of polypropylene waste is used, and consequently the production of electricity is not much. The use of pigmented polypropylene supports a significant reduction in energy consumption and atmospheric CO2 emission from combustion processes, allowing also the elimination of emission from the pending process. Recycling is economically sustainable if the investment cost of the shredding system is equal to or less than €10 per kilogram. Thank you for your kind attention.
Thank you very much, Senator, for your presentation. This was really very interesting. And maybe I just have a question to start. So now you calculated a lot of scenarios, but do you have or do you see one or two of these scenarios are the best options for the manufacturing plant, either from a cost or from an environmental perspective? Or do you see there are more or less equal options. Maybe you can elaborate on this a little bit.
Okay, the scenarios are elaborated the environmental constraints are imposed to the system, and the model optimize the total cost of the system. So the optimization phase is finalized to individuate the lower economically solution. The environmental aspects are introduced as external constraint to the model. So we obtain the solution characterized to lower costs. And this is a work. This study is carried out in collaboration with an Italian industry, and they suggest us their possible evolution of the political of a plant, and we introduce their suggestion in the model.
Okay, thank you very much. Then I hand over to Simone. Do we have any questions?
Okay, thank you, Senatro, for your presentation. Actually, there's no any questions in WOVA and in the chat. But maybe can I ask you? I put one question for you, and you can reply now, and you can also take time to think about. What about the long-term consequences of alternatives? Since if I understood well, you have considered only up to 2025 scenario. But for example, for photovoltaics, we can imagine that the plant will at least produce energy for 20 years.
Okay. Because in this application, we have analyzed a very short period respect to the potentiality of the model typically used for energy system, regions, country on European energy system. But the model is driven from external demand, in our case, the car production, and we have this period because the Italian industry don't provide information after 10 years. So the horizon time is very short respect to the usual application, because they can't provide indication on a car production after 2025. It is already for industry. This period is already longer respect to usual forecast.
Okay, but of course, if we thought about the decarbonization at least we have
Yes.
plan longer. And I have a small question regarding the cost of shredding. You put from 60 to 10 euro per kilogram investment. What do you mean per kilogram?
For
in terms of capacity, is 10 kilogram per day? Or how? Since I can imagine that the cost of the material is less or it's some euros per kilogram. So what's the cost in terms of capacity? Is 10 euro per capacity in terms of kilogram per day, kilogram per hour, or?
This is an information that Italian industry provide us, but I think that it is a cost related to the flow of material, and
so it's kilogram per hour.
Yes.
So the capacity is okay. Okay, fine. Okay, fine. Thank you very much, Senatro. I left the question also in UVA. Okay. We have a difficult connection, so I cannot hear you very well. So I suggest Andrea to introduce the second speaker, and then, of course, at the end we will have additional space for other questions. At the moment, there's no any questions from you for you, Senatro.
Okay, thank you very much, Simone. Then we will continue with our second presentation, which is from Sara. Sara works as a senior researcher at the Division of Mobility and Systems at RISE Research Institutes of Sweden, and her research deals with the cross-section of digital innovations and circular economy, with a strong industrial focus on the transition towards circular business models. And today she will talk about transparency to the circular flow of batteries.
Thank you so much, Andrea, for a great introduction. Good day, everyone. I'm very happy to share preliminary results of an ongoing project that we have at RISE in collaboration with Chalmers Industriteknik and EV Ledger, which is also a Swedish Gothenburg-based company looking into circular solutions for batteries, specifically from EVs. So let's see if I can move towards yes. I assume that many in this session know the background to circular economy and the topic, but I thought to just briefly start with that how circular economy can manifest in several activities along the product life cycle, from product design to sourcing to manufacturing, logistics, marketing, use phase, and also end of life. And the focus could be different depending on which part of the life cycle you are looking at. It can be repair and maintenance, upgrading or reselling of the components, remanufacturing of the components, but it can also be recycling and sourcing back the material in new production. It can be also about increasing the utilization through servitization and product as a service models. So in this project, the framework that we are using, we have clustered these several activities that we see in the literature, but also in industry, and the focus on circular economy in these 3 dimensions, and looking into which dimension is more reliable and feasible and viable when it comes to the flow of batteries. So when we talk about recirculation, it's basically about how much of a product's material comes from a prior use phase or returns to another use phase. When we talk about endurance or extending the life, we are basically talking about how well does a product retain its value and remain attractive basically during its life cycle. And when it comes to utilization, we look into how much or how often is the product used during its functional lifespan. So it's basically about intensity of use during the product's lifetime. We are applying that framework on this specific context of circular flow of batteries. And what we are interested in specifically is if we can improve and increase trust and transparency between the different actors in the circular value chain for the batteries by developing a solution or a tool that uses blockchain to verify and track performance of the individual cells. And I will give you a little bit of background why we have got to this point. But this is basically an ongoing project that started in November 2019, and it's going to continue until end of June next year. It's financed by Vinnova, and we have also a strong reference group, including several actors in different parts of the value chain, from the OEMs to potential second users like energy companies, or also fleet owners that would benefit in a different way from value preservation when it comes to circular flow of batteries. We are drawing on previous research that we have had on similar topics in the past, where we had different focus. We have in previous projects, Chalmers Industry Technique, which is our partner, has looked into the aftermarket and take-back systems for the lithium-ion batteries, basically mapping what happens to the batteries after their first use in a car. If there is a need for removal of the batteries from the vehicle, or if they should be replaced, and which actors sort of are responsible for that. And also in terms of the activities, what needs to be done in terms of diagnosis, preparation for reuse, preparation for second life, and also pre-treatment for recycling, and finally the actual recycling. And how to sort of set up a take-back system that sort of follows this sort of logic for improving the circularity of the batteries. We have also looked into several barriers and opportunities that we see basically with second life and also with recycling in a previous project, which was a collaboration also with industrial companies in Sweden. And there we sort of looked into 4 different business model scenarios that we could imagine for batteries from the EVs. And these scenarios are quite different in terms of the customer value proposition that is offered in terms of circularity, but also in terms of the network that you would need, or the business ecosystem that you would need to orchestrate them. The linear model is basically what we have today, where you have a battery production and used in a vehicle, and then hopefully material gets recycled. And to optimize that by just looking into how we could improve the value network by closing the loop from the recycling. Batteries could be material for the batteries could be reused in production of new batteries. So that's optimized recycling sort of, and we could have different business models sort of connected to that as well. But we could also have improved customer value proposition, where with the current ecosystem, we could have a battery production and use in a vehicle, followed by repair and refurbishment for second use in a vehicle in the same or in a new market, and state-of-the-art recycling after that. And if we extend the ecosystem one step further, then we could have, after the first or second life in a vehicle, we could have a repackaging and second life in another application, such as energy storage solutions, for example. And after that extended life, we could have a state-of-the-art recycling. So we are looking into this 4 scenarios or business models for the batteries, and as you know, there are potential opportunities for second life applications, specifically focused on storage or of solar or wind power, for peak shaving, for EV charging, for increased grid capability and stability. I know that Reinhard has an interesting presentation after this one on energy storage solutions specifically, which is connected to this presentation as well. I'm really looking forward to that one. But besides these opportunities, we also see several barriers when it comes to enabling these business models. When it comes to second life, we see that there is an interest in the market, but there are also some uncertainties caused by, for example, regulatory frameworks that exist today that doesn't specifically put any responsibility on the producers or the OEMs to to invest in second life business models, so to say. We see uncertainty around like future chemistries, future technologies that would justify the investment that is needed today for the processes, for setting up the processes that are needed for remanufacturing or refurbishing the batteries. We see lack of standardization beyond the cell level in the modular and pack level that is causing like technological barriers sort of to move towards these business models. And also when it comes to recycling, we also see that there is also risk of investment, as I said, for large scale processes when the future projection for battery chemistries and technologies is a little bit still uncertain, and also aligning the investments for future business models that are with like, so that they are not conflicting with the existing business models. That's also a challenge. And what we kept hearing from the actors was that they are really interested in more collaboration, but they don't necessarily have the platforms for that all the time because they don't really fit into their traditional business models, the way that they were working and the ecosystems that they were working in. So what we are then trying to look into as a hypothesis is if we could have a distributed data verification model that optimizes the reuse of knowledge and minimizes both the cost and the environmental impact of the batteries, basically by moving from this linear scenario that I have in the bottom of this picture to the right-hand side scenario where you have the extended ecosystem and you can have data exchange from mining to refining of the material to cell manufacturing to pack manufacturing to first use applications, repurposing after that for a second life application. There could be an extended life even after that for a third life application, and eventually to recycling. And we are looking into, we have talked to actors along this extended ecosystem, OEMs, dismantlers, workshops, insurance companies, recycling companies whatsoever, and basically asking them about their ideas, their strategies for circular economy, specifically focused on batteries, and the role and position that they can imagine for themselves in the future ecosystem, the information that they have access to today that they are willing to share, and the data needs or wishes that they have for functioning in this future circular value chain. And our findings so far indicate that most actors are interested in sort of hands-on information about battery health status, but they are also interested in having the specifications about the chemistry or design and construction of the batteries. When it comes to traceability, current interest is very much into when it comes related to material sourcing, and not that much has yet discussed in terms of value preservation. That is sort of the potential in when you have traceability along the ecosystem. And they also say or point us to the need for distributed data collection points to take care of pre-treatment and dismantling and preparation for recycling of these batteries. We have tried to sort of map, this is a quite complex and distributed system, and that's actually the point, to show you that like if you look at the blue lines here, that's the data flows that we have sort of today between the different actors. And if you look at the red lines, those are the information needs that we have understood from our interviews that we would need to have in the future system, also supporting functions such as insurance, transportation, and service. So obviously, one thing that we have been discussing with the actors, and we are also realizing ourselves, is that orchestrating that complex data sorting and data sharing network and also the infrastructure that is required for that goes beyond the current business models of the stakeholders. They are sort of, many of them have hundreds of years of history in working with a certain business model. So now what we are looking into in the continuation of the project is to have like our hypothesis is an alternative setup where we have a third-party validation of information, like if we could resolve this by a battery information gathering, an entity that distributes the data, individual, sort of cleans data based on the needs of the different actors, and also acts as a third-party certification validation actor, and increases the sort of the usage of the data between the different actors, from dismantlers to recycling companies to manufacturers, and also then support the sort of the add-on functions that are required in terms of transportation, insurance, and financing and services that we would need for these, for the circular business models of these batteries. Hopefully through that, we would have some immediate business effects in terms of enabling the operation of these business models specifically for repurposing and reuse, which is still, there are several barriers for that today. And also maybe a little bit go outside the existing context, which are naturally, we would, of course, we would also be interested in B2B context, but also in C2C or C2B setups where customers can resell the batteries that they have consumed in a verifiable and in a safe system. And over the long term, of course, the contribution would be towards resource efficiency and that we would need when it comes to future volumes of the batteries that we have. So that was my last slide, and this is the team behind this project. So please feel free to contact any of us if you're interested in discussing this subject, if you have projects alike. So I'm really looking forward to the network that comes out of this this conference. Thank you so much.
Thank you so much, Sara. This was really very interesting. I'm also looking forward to see what you generate as results in your project. And maybe I have one question. So you also mentioned that you need rather technical data, of course, because if you want to close the loop, but then I'm not quite sure, how do you perceive the willingness of the companies really to share their know-how with other parties? Because often we see, when we look at energy efficiency networks or something, that companies are willing to share if the other companies are not somehow direct competitors. But how would you perceive the loop here and the willingness to share sensitive information?
I would say that that is a very relevant point, and that is something that we are trying to explore. What's the potential of using blockchain technology for that? Because what we are interested in is that to set up a system where the actors don't necessarily need to share the raw data, but we have a verification process. So you don't have to know the actual data, but you get information about if that data is trustable or not. And I think many actors are more interested in that because that is sort of the risk that they foresee in making investments today, because there is sort of no way for them to verify that data beyond, like, or besides actually having the data themselves and doing the analysis themselves. So that is one idea that we are looking into in the project, with the potential for like enabling what blockchain can enable sort of in this setup. Maybe next year I can sort of share the final results of the project in the next year Industrial Efficiency Conference. But that is absolutely something that that is also the purpose of this project, to solve that problem.
Thank you very much. Then I will hand over to Simone.
Okay, thank you very much, Sara, for the interesting presentation. There's a couple of questions from the audience. Margherita Cumani asks, in your experience, is the refurbishment able to restore the initial efficiency of batteries? And I would add, what's the actual technical knowledge on batteries refurbishment and expected advancement on it?
If the refurbishment actors today can sort of can evaluate, I don't think that today, because it seems like I'm not an expert in that, I must say, but that is something that is that has been communicated, that it's like there is some sort of lost data, so to say, from the use phase that would actually make it difficult for the refurbishing actors to sort of at least have a sort of an optimized process, a profitable process for evaluating the capacity that is left and the life that is left in the batteries. But of course, that is also something that there is a lot of potential to solve that through distributed data systems. Then we might even be able to get more hands-on data on about the use phase, which would sort of help these actors to evaluate the potential for the second life, and then have a more optimized sorting based on that, if they have to be refurbished for second use or if they should be sent for recycling directly, and what type of second use they can imagine.
Okay, thank you. There is a second question from Mathieu. Did you look into the scenarios where batteries are often replaced during a car's life? So instead of having to plug the car, you swap unloaded battery for a full one?
We haven't looked into that that much, I must say, but that's an interesting business model as well. Today it's a bit uncertain to have comparisons really of these different models, because we don't have that many volumes to sort of from the different scenarios. Not that many in EV sort of have reached their end of life to look into battery swap versus one battery for the whole lifetime of its being in use for its full life. So we haven't specifically looked into that, but that is a very interesting scenario. Maybe we could I didn't catch the name, but maybe we should connect if they have some ideas by this audience member on that topic. I think your mic is muted, Simone, so I cannot hear you.
We can have an additional question. Thank you, Sara. Would an eco label like the Blue Angel be useful for second life batteries?
I'm sorry, I didn't catch the first part of the question.
Do you think that a specific eco label should be useful for incentive the second life of batteries? There are plenty of different experiences.
Yeah, exactly. It could be a good, today it seems like I think it could solve some of the incentive problems that we see. Because today, it's a bit difficult when we talk about the business case versus environmental case, it's a bit difficult for some companies to actually justify why they should invest in this type of circular business models when we only look into the money that is generated. And I don't think that the money is not like, I don't think that it won't be profitable, but I think it would be even more timely to have sort of certification models for creating even more incentive and putting more responsibility for the actors to look into these circular solutions. Of course, like using digital technologies such as blockchain is a sort of an alternative to these certifications that sort of does the same function, but they could be also orchestrated by other entities, authorities to have these labels.
Okay, thank you very much, Sara.
Thank you.
I think right now there's no any additional questions. So I think that I can give the floor to Andrea to introduce the third speaker of this session. Thank you very much, Sara.
Okay, thank you, Simone. Our third speaker today is Reinhard, and Reinhard works with the Grazer ENERGIEAgentur since 2009, but he's even longer in the field of energy efficiency services. He's active in various national and international research projects, but currently he's, among others, coordinating the project Second Life Batteries for Storage. And about this project, he will talk about today. So Reinhard, the floor is yours.
Thank you, Andrea. And thank you for the opportunity to present this project to you. I realized that my presentation will effectively complement Sara's presentation very much because I'm talking specifically about second life of e-mobility batteries for the usage of stationary energy storages. And
Reinhard, I cannot hear you.
Great. Can you hear me now?
Yes.
Okay. Have you heard nothing of what I said?
I heard the title, and then you moved, and then you were gone.
Ah, okay. Yeah. So I realized that my presentation will complement a lot of Sara's presentation, and in our project we concentrate specifically on second life of e-mobility batteries for the usage of stationary energy storages. Okay. this is just to summarize again what is Second Life when it comes to batteries. Okay, we have the application in mobile usage, and when the efficiency factor of a battery is down to 80% or 75%, it's possible to use it for stationary purposes again, because you are not bound to weight issues and so on. After Second Life, or maybe Third Life, as Sarah mentioned, there's still the possibility to do recycling, and we assume that the value for of the materials would be the same, no matter if it's after First Life or Second Life. So why Second Life batteries for storage? There are two sides of the story. One is we all know that energy storage systems are becoming increasingly important, and batteries are specifically usable for short-term storage, not to talk about seasonal storage, of course. And the other side is that we could expect that used battery systems from electric mobility will become more frequent the more electric cars are in the market. To bring these two sides together, there's a gap in between when it comes to making a market, creating a market for this field. And the question is how to assess the value and the optimal reusability of used batteries. Because from First Life batteries, you can assume a certain standard of a battery, but if you take it out of any given car that you don't know very much about, of its history, it's not so easy to detect the value. So we built a whole environment, or at least we want to build up a whole environment for this market segment. So on this slide, on the left-hand side, you see the existing system with the EV use, the First Life cycle, and directly going to the recycling phase. And in the middle here, we have this interface between the two worlds where we can enter the Second Life cycle. What do we need for this? We need something to estimate the value of a battery. Therefore, we the first part of the project is the development of a rapid testing device for the state of health determination of Second Life batteries. Second part of the story is what can we do with these batteries? And we are designing a calculation tool for different storage dimensions and storage usages. To prove that this system works, we will have a demo plant, a demo container with a Second Life battery system. And last but not least, we are creating a benchmarking tool for determining the residual value of the battery systems and compare it between the systems if we go directly to recycling or to a Second Life. Regarding the first module, the rapid testing device is a thing that is currently under development. We have a prototype yet, and it works like that we first eliminate the foul X in batteries through the measurement of current and resistance, which is done quite easily. And the batteries that pass this test come forward to a simple capacity test and then a long-term test with a sophisticated algorithm. This testing device is of good use, for instance, for used car dealers or for leasing companies to estimate the residual value of a car and its battery, but probably also for repair shops or automotive clubs. And very interesting, and we have one of these companies also in our consortium. It might be interesting for disposal companies that get their hands on these used batteries and want to increase the value chain for these batteries. Last but not least, it's also interesting, and we have heard of a lot of interest from OEMs, original equipment manufacturers, that, by the way, are not part of the consortium. So we don't have an automotive manufacturer in the consortium, which makes it more challenging to get a grip on data of batteries because we can rely on existing interfaces. So the battery is all in all a black box that we want to find out information. The second module is the storage dimensioning with second life batteries. The basis for this is the load profiles of any given object or company. That means that we need a quarterly hours consumption profile of a company that you get from your utility service company. And this enables us not only to work with default profiles like many other market players do it, but create a dimensioning that is very much individualized for the specific company or place where the battery should work. The tool is programmed for the use of second life batteries, but of course, as we have not so many second life batteries nowadays on the market, it's also usable for first life batteries as an intermediate solution. And yeah, the next slide is more or less something we have already seen in Sara's presentation, but with a reduced focus. So who are the stakeholders, the players in this field, the customers, and what are the applications for these second life battery storages? And in this matrix, we see that, for instance, if we have the purpose and to have an alternative to a grid expansion, because we can use batteries for reducing the peak load, then there are different players who can apply it. For instance, it's the residentials themselves to reduce their costs towards the utility, the grid provider. It could be the grid provider himself, or for instance, it could also be an e-charge provider if the costs would be high to increase the load of a given grid line. So with our dimensioning tool, we concentrated on two usages. The first one is peak shaving. After a lot of calculations and turning the coin upside down and viewing it from different angles, we came to the conclusion that, at least for Austria, it's currently not economic to use these storages for peak shaving, as the power tariffs are very low and still the battery tariffs are too high. So we would need much lower battery prices here for having an economic situation. In Germany, we learned it's a little bit different, because power tariffs are sometimes doubled or 3 times the price. The second application would be to have the battery complementing a PV, a photovoltaic site, to increase the self-consumption of your PV modules. In this field, we can already reach economic situations. With this tool, we calculate the net present value of different constellations, and we at least try to make an output that is also understood by financial people of a company or an organization, and not only the technical people, to make life easier in coming to a decision in companies. The third module that I just will briefly refer to is the benchmarking tool. This compares the paths going directly to recycling and using the materials again for manufacturing new batteries, or the path with a reuse phase in between, and this should be very valuable database, especially for companies that work in battery development, for finding new value chains for their products. And the highlight, let's say, is we are currently building up a pilot site with a semi-portable storage system that can be transported in a container. I have to admit it's quite small because it's just about 100 kilowatt hours, and we have compared on the market. There are, of course, a lot of pilot projects with much bigger storages, but on the other side, all these other projects have at least one car manufacturer or battery manufacturer in their consortium or on their team. We are really independent from these car manufacturers. So on the left side of the slide, you see a sketch of the container, and in the center of the slide, the already built up container that has been assembled now in Germany and will be transported to Austria for the first usage. Okay, that's our hope, that's our vision. We want to help to create a free market for used battery systems in order not to let this field open just for the OEMs, and that, for instance, disposal companies or car manufacturers or private people can also play a role on this market and make good use of the products that they have purchased or are in their custody. Thank you for attention.
Thank you very much, Reinhard, for this very, very interesting presentation. And I might still have one question. And you mentioned that at current battery prices, the peak shedding is not economically feasible. And I wanted to ask you, what kind of battery prices would you need to make this also a viable option? And do you see scenarios where these battery prices will, in reality, and when be achieved on the market?
That's a very interesting question. So for Austrian circumstances, with the current tariff system, the prices would have to be very low. So it would have to be around 200 euro for the whole per kilowatt hour for the whole system. So not only the battery price, and this is very challenging because we see, of course, that also new batteries are going down with prices. So this is more or less a market competitor to this scheme, and we must not forget that there is also some engineering effort. You need a lot of time and resources for setting up the system, when you have inhomogeneous batteries in the system.
Okay, thank you very much. Then I hand over to Simone.
Okay, thank you very much, Reinhard, for the very interesting and applicative presentation. At the moment, there's no any left or there's no any questions. Just let me pose you a questions regarding the safety of this, let me say, container, portable container. Is this this might some I don't know, fire or explosion protection, since if it's portable, I know that if it's let me say steady in a place, it's okay. But what about transporting it?
It's a very interesting question. In the first place, all these batteries have been mobile ones. Yeah, so they have all been integrated in any car. And well, now they are disassembled in a way. But of course, this is a very important issue. So why we call this container a semi-potable container is that we have to get the batteries out for transportation purposes and transport them separately. The container will be transported separately, and then again assembled at the place where it will be installed. And effectively, there are, at least in Austria, just a few companies that are even allowed to transport used batteries.
Okay, yes, I can imagine that right now it's a big issue how to transport used batteries. It's something to manage. I don't see any additional questions. No, Wova, no questions. So I give the floor to Andrea. Thank you very much again, Reinhard. And maybe at the end of the session, there will be some floor for coming questions.
Thank you.
Okay, thank you. So our next speaker is Elvira Rakova, and she has a PhD in mechanical engineering from Dresden University and is CEO of the company Direktin that focus on the optimization of energy efficiency of compressed air system in industrial plants and machines. And today she will talk about novel business models, how to reduce energy consumption in industrial automations. So Elvira, the floor is yours.
Thank you, Andrea, for your kind presentation. Hello, everyone. So I tried to adjust my slides and my phone so that you can enjoy my presentation also on the mobile phone today. And I would like to talk with you about the efficiency of compressed air systems. Sometimes it's very underestimated. For example, yesterday I saw a presentation where it was a ranking of the priorities in industry. And it was shown that compressed air efficiency already exceeded all the potential. And this technology is sometimes, unfortunately, considered as an old technology. So I would like to refresh it up a little bit today and show you a new business model, a new platform that we are proposing for everyone who uses this technology. So first of all, I don't want to bother you a lot with the numbers. We're in an energy efficiency conference, so you already know all the consumptional struggles and all our goals for the future. What I just want to point out here is the number of the compressed air, how much the compressed air consumes in the industry. So it's 20% of the total industry consumption, circa, at least in Europe. This is the latest data that consumed by compressed air. So it's not only processes, but also automations, processes, automotive processes, and handling and packaging. So there is a very vast application for that systems. So let's just have a look and see which potentials we have. It's been already done huge work in this field. And I just want to show you what is actually the compressed air and where we have to focus on. So it usually we have a factory and we have some production there, and in the factory that uses compressed air for the processes to maintain some goods. For example, we have a compressor room, we have a distribution line, and we have then the production machines. Very common practice when the energy agencies, when the governmental organizations started to work with the problematic of compressed air, they start with an audit of the industries that actually use compressed air systems. And it's actually very high potential to save it and to reduce it. So up to 40% savings only due to audit and maintenance in the correct time can be achieved by that. But actually 70% savings can be achieved by the efficient design of each part of the system. So by the compressor, distribution, and the production machine in the design phase. So just to point it out once again, 40%, it's the top of an iceberg that is proceeded right now. And that I think it's a very good direction that everyone follows and industries are actually capable to do right now. But 70%, we still have a lot of potential. But to understand it, we need just to see where this problematic, where this potential lays. So we have this circle. So today we've been seeing a lot of circles. So it's not about the reusable or goods, but it's about the actually energy circle that we have here. So we have a component supplier of pneumatic components. It can be valves, cylinders, tubes. The component supplier provides his components to the machine builder that installs these components. Machine builder, on the other hand, provides it to the end user, and end user compiles this puzzle to finally use the compressed air in his line and produce goods. So the question is how we can motivate three parties of that. So I like this slide because we usually motivation, like sometimes it's really hard to find motivation, but sometimes it finds us. And what I think it's really good, what we have a lot of in this conference we're talking about, it's about standards, guidelines, frameworks, white papers that we actually have to provide to end users, to suppliers, green labels, so that they can actually be motivated by that. But also I think that the most important part of that, one of the aspects, it's the motivation not only from bottom up, but also bottom down. And bottom down, I think from my perspective, is more or less like positive thinking for engineers, that they really have time to make an efficient design. They have also energy to evaluate all the energy saving measures. And of course, it's not only the personal motivation or motivation of a management, but it's also, this has to be easy. So usually we have standards, guidelines, at least in our field, it's 40 to 60 pages. I've been working also on that side, and trust me, it takes really a lot of time. And if company doesn't have a special person who is focused on energy saving measures, they're probably not going to implement it. And but if we have some tools or something that can provide engineer easy design of his system and can really fast evaluate just energy saving measures, that would be an ideal case, of course. So let's just see how we can motivate three of these parties. So for the end users, I would say it's really easy, and this is now state of the art. It's a reduction of energy cost. End user use the compressed air. He pays for compressor, he pays for kilowatt hour, and this is actually how we can motivate him by optimizing his network. For example, we can optimize his design network. And just by optimizing the network, we can save up to 30% of consumption of compressed air systems. So I'm not talking about the audits, but just like establishing the correct topology of the network. After establishing that, it's also important to have a software for condition monitoring of this. So we have leakages. We cannot hear sometimes when the air is leaking, so we cannot smell it. So we need to install some software for condition monitoring to avoid pressure loss. And the motivation to do that, it's very easy to find because it's an energy bill for the end user. So you can show the payback periods of his investment for that. And it's not like a rocket science for that. So let's think how to motivate now an engineer. The problem is that engineer of the machine builder that is building the machine, right? The problem is that the machine builder doesn't use the machine, so he doesn't pay for the consumption of compressed air of the machine. There are no green labels like in the washing machine right now for the industrial sector that says this machine is efficient. And there are not, at least in compressed air system. And it is only the ISO standard that is coming up now in a couple of years, actually, to optimize the pneumatic systems. And for engineers, it takes quite a while just to think about efficiency of pneumatic system. But let's imagine we have a tool, and I have here a short video for you. Imagine that you're an engineer that wants to work with a pneumatic system, and you actually can calculate all your parameters of your system, and you actually can calculate the energy consumption of your system just in a one click. So you just input your parameters, you have the energy consumption, you have cost per year, you understand which part of your system consumes how much. And what is the most important also thing, that you can see which energy saving potential you have in your system. So basically there are various energy saving potentials that are available for pneumatic components, for compressed air components. And here you can see payback periods if you apply them. So for example, in this case, for that scenario, it's 6 months. For this scenario, it will be 1 year. So an engineer already can evaluate it. He can just print it and show to his end user that is going to buy machine. He's going to show the reason why the machine is now maybe a bit more expensive. But look, if you have this operation hour of your machine every year, then it will pay back you in 6 months. So this platform exists already, as you can see. This was the result of research, 5 years research. And this is available for engineers that work with compressed air systems, that work with pneumatics. So I would like to show you now a 1 minute cartoon video, just to give you an idea if you don't work in this field. So just relax and enjoy in case you are. The idea is to make the life so, and the platform is supported online and so this is how it works. So I just showed you the first model where the engineer can calculate the then the most important part, can connect wires. And basically have everything in one. So the idea is that so Abena, could you please pass the next slide, please? Thank you. The next slide, sorry. Thank you very much. So the idea is that of that platform, that it's not only evaluates the energy performance of pneumatic systems, but it also connects with the component supplier. So it will, in the next phase, it will connect with the component supplier, and the machine builder will see, okay, what is the most convenient energy saving solution I have for my problem. And this is the next step. And I think what is the most important thing, that the first model of the efficiency evaluation and also component choice, it's free of charge. So it's available now for each engineer. And our business model looks like that. So we have a component supplier that provides an efficient solution. It connects through our platform that calculates it, that have this intelligence behind, with the machine builder. And machine builder can easily apply this. So without reading a lot of books or any white papers, he can just apply it, evaluate it, and give a feedback to component supplier. But we also hope that in the future, that by promoting the new efficient solutions through our platform, the price of efficient solutions for pneumatics will be lower. And it actually will be like more trendy to use efficient components, to produce efficient components than it is now. That is now the case. So our idea, as I said again, our vision also that energy efficiency is easy and it has to be available for everyone. So for each engineer, so some tools have to exist not only in the compressed air field, but also in other fields like in battery fields, the presentation we saw before. Easy to access and also to connect with the companies, with the small companies and support small companies that do make efficient solutions, also to implement it. So our team, we are 3 companies, all of us based in Italy. And our goal of this presentation today is also to connect with the energy agencies and industry representatives. So who is interested in the topic of compressed air efficiency. So please just contact us and we'll be very happy to collaborate. Thank you very much and have a great day. Looking forward for your questions.
Thank you very much, Elvira. And maybe one question from my side. So how is the feedback from the engineers or to your tool? Do they already use it, or do you see some skepticism on the side of the engineers? So how do you perceive this?
Yes, thank you for your question. So actually, we launched this platform 3 months ago. So we have engineers that are testing it, so they're quite happy about it. But the thing is here that they are already trust to our knowledge, to our expertise. And of course, there is a lack of credibility in the field. But good side of it, that we work also with some governmental organizations, and I also work as an ISO expert in this field. So we're still trying to promote it also through component suppliers, and just to see, because there are not so many, there are no tools like that to evaluate this energy performance right away. So, but we're very optimistic about it. So, but of course, the credibility issue can be one of it. So even it is like based on PhD, on some research or ISO standards, some people don't want to change their habits to use some other tools. So, but we'll see how it goes.
Thank you very much. Then I hand over to Simone.
Okay, thank you, Elvira, for the interesting presentation. Just looking on UVA. At the moment, no questions rising from the audience. I have a specific question for you, Elvira. I know that in dealing with compressed air, one of the interesting energy efficiency intervention is the heat recovery in the compressor unit. Have you already considered this aspect in the design of your tool?
Yeah, thank you so much. So heat recovery is on the compressor side. So basically it's the end user side. When you saw my presentation, I divided in the end user, so compressor distribution machine, the one who already use it, together with compressor. So basically what we do, we provide the optimizational strategies, so more or less on the consultancy level, and we consider the heat recovery. The tool is focused right now only for the machine builder. So there is no heat recovery needed in the machines because there are no compressors there. So, but we consider it for the full chain, yes. But there is no calculation of that inside the tool for machine builder.
Okay, there is a question on UVA for you, Elvira. Are you considering linking this to some financial scheme? And how are you reimbursed for your service from companies?
Yeah, so the scheme is that we are now contacting the component suppliers of the components actually to link their databases to our software. As I told you, now it's just choosing and showing, okay, you can use the option A, it's going to save you 40% and your payback period is 2 months. So now we are trying to link it with the cases already, so with the component suppliers. And the business model is based on the subscription. So the component suppliers database, so it's promotion and evaluation of his solution to our for our scheme. And another thing we have also not pay, so not paid, it's the energy efficiency model. So the first one, the essential one. And the second one, we have also the smart BOM, some bill of material where the engineer can already do the documentation. So the documentation, and also in this BOM, for example, if the engineer already have the components to put it together, it can calculate automatically energy consumption of that. So there are some parameters of this. So this is more advanced tool. This is already all subscription based for engineering companies.
Okay, clear. The situation is clear. Elvira, thank you. Okay, let me check. Okay. No, in UVA. Okay. Another question from Soon Lee. For the analysis tool for compressed air system, are the dryers part of the consideration?
So dryers is the part of the consideration for the end user. Yes. So for the it's a full chain from the compressor to the end user. Yes.
Unless at the moment the tool is concentrated on the
enough for the machine builders. Yes, but the models that we use in it also includes
comprehensive. Yes.
Just different targets.
And what about? I know that different players in making pneumatic and compressed air systems already provide some tool. Probably they are just for them. So you are aiming to provide something that is a cross-platform that can allow using different and maybe you can, as a machine builder, compare the performances of different, let me see, assembly options.
Well, it is ideally, of course, this is our goal to unify everyone to save the energy in pneumatic systems. But we already, for example, provide platform for Artema. So it's the French organization of the machine builders and the component suppliers, where we are building the database, for example, for the distribution line, optimization of the full distribution line. But of course, some cross-engineering platform for energy efficient system, I think, in my opinion, it's something that we really need in all fields, not only in the compressed air, or some smart marketplaces where we can evaluate efficiency.
Okay, thank you, Elvira. And an additional question, also regarding the tool. Is the tool capable also to suggest other alternatives like electric, that is non-compressed option? Maybe in some cases it's useful not to use air compressed and replace with an electric driver like this.
Yes, I agree with you, of course. So the tool, we are working now on the first model, because this tool that I showed you is mostly for the linear motions. And we have also the programming of the tool that compares with the electric drives. So we didn't launch it yet, but it was a topic of my thesis where I compared pneumatic and electromechanical systems. So we're trying to making it now happen until the end of the year.
And there's again another very specific question on the tool. If it's capable also to capture other benefits like optimized space design or reduced space occupation.
Yeah, good question. So what we work now on, it's actually the ecological performance. So there is now a new standard of the metallic manufacturing parts. So it's going to be also another model by the end of the year where it's going to calculate ecological performance of the parts. And the space and safety measures, these are two aspects that we would like to work on further, but it's not there yet. It's not available yet.
Okay, thank you, Elvira. Interesting presentation, a lot of questions. So feel free also to reply in UVA after the presentation.
Yes, for sure, and feel free to contact me also after. I would like to talk to you. Thank you.
Okay, there are still a couple of minutes. Maybe Andrea, you can resume the work and maybe say that the appointment is in half an hour for the fourth session of this panel.
Okay. Okay, so thank you very much, especially to our presenters. It was a very interesting session. And so today we learned a lot about the production process in the automotive industry and how to optimize this, or which different pathways are possible. We learned that there are efforts how to increase the circularity of the battery value chain, and especially we also talked about how could then such a market look like for reuse or second life batteries. And in the end, of course, what we see now was a tool to facilitate the efficient energy use for compressed air systems. So I think this was really a very interesting session. And in half an hour, we have another session, our last session for panel 2. So we would be very happy if you join us. And then we will talk about energy and material efficiency along the whole value chain. And if you still have questions for any of our speakers, then just write them directly or via Wova. They will gladly answer your questions. So thank you very much. Thank you. Bye.
See you in a half an hour. Bye.